Hello everyone, this is Vikram and welcome to my channel. In this video, we are going to talk about AWS IAM service in depth. These are the various topics we are going to cover. We'll understand what is principle of least privilege, what is AWS IAM service, IAM users, groups and roles, the difference between IAM user and an IAM role, what are IAM policies and how to attach these policies to users and roles. In how many ways you can access AWS. Basically, you can access AWS through Management Console and through AWS CLI. We are going to understand the difference between these two. And then we'll try to create an IAM user with programmatic access. That means only through AWS CLI and through some programming scripts, he'll be able to access AWS services, but he will not get access to AWS console. In order to understand this, we will try to install AWS CLI on a Windows machine and also configure it to talk to our AWS services. So this principle of least privilege states that a subject should be given only those privileges needed for it to complete its task. So here you can take a subject, you can take the subject as a user. So if a user has to create S3 bucket or have full access to the S3 buckets in AWS, so I should only give him the permissions to access or modify those S3 buckets and nothing more than that, because that is the only permission needed for him to complete his task. If a subject doesn't need any access, then that access should not be given to that subject. In our case, it is a user. So granting permissions to a user beyond the scope of necessary rights so can allow that user to obtain or change any information in unwanted ways. Let's say I unnecessarily give an administrative privileges to a particular user. Since he has administrative privileges, he can do anything within your AWS account. That means he can even delete some of the important resources. So this could potentially damage the system. So you should only grant the permissions that are required to complete his task. So this is the principle of least privilege. And also careful delegation of access right can also limit attackers from damaging a system. So if they gain access to an IAM user account, since we are restricting that IAM user to perform only certain activities within the AWS account, even the attacker gets to access his account, so they cannot do anything beyond the permissions that are assigned to that IAM user. And every program and every user of the system should operate using the least set of privileges necessary to complete the job. So in our case, let's say a user has to create EKS clusters, then I can just give him EKS full access. Other than that, that user doesn't need anything. So this is the least privilege. And coming to the IAM, we will understand what is this IAM. So IAM is all about what a user or a process or a service or a bot can do in your AWS account. So there are two types of users. Basically, he can be a user who logs in from UI and who has passwords, or it can be a service or a bot account or a service account. Even that accounts when you're trying to do automation in your AWS account. So those sort of processes or services themselves need to authenticate with your AWS account. So IAM is all about what a user or such a process can do in your AWS account. And IAM controls who can do what in your AWS account. So here who means who comes under the authentication part and what comes under the authorization part. So who can do what in your AWS account? Like I have a user X. So what that user X can do in my AWS account? So does he have full access to all the resources, or he only got access to EC2 services? So this is what controls the authorization. So authentication with IAM is usually done with users, groups and roles, because as we already know, user is just a user, but role, we'll understand what is a role. So authentication is managed through users, groups and roles, but authorization is managed through policies. So policies defines basically what a user can do to a resource. Let's say I can grant a X user a permission to only list S3 buckets, but not creating or deleting S3 buckets. So I can have fine-grained control through authorization. So IAM stands for Identity and Access Management. This is the core of AWS security, as it allows you to create users, group, and also grant permissions for them and also assign policies to specific set of users. And if you have root account, so you can also create your own access keys or set of multi-factor authentication. So you can do everything in IAM. So by default, as we know that whenever an AWS account is created, so root account will be automatically created. So root account is the first account. So if I want to create multi-factor authentication for that root user, I can actually create using IAM. And coming to the root user, so root user has unrestricted access to your AWS resources, which means he can do anything within your AWS account. Assigning him various policies is not required because he has full access to your AWS account. And also you can specify various permissions to control various operations within your AWS account through permissions, and these permissions can be basically attached to either a user or a role. So when I talk about role, so you can take it as a specific AWS service, or it can be a bot account, or it can be a service account. So anything who is not a user comes under a role in case of AWS. But remember, role is similar to user, but there are some differences, but operations wise they are similar. And as we already know, AWS IAM service is free to use. So AWS IAM can be divided into two different sections. One is the identity in the sense it's the authentication part basically. So it can be user, it can be group, or it can be a role. So role, as I said, it can be a service. It can be an other AWS service, or it can be a simple process, bot, whatever it is. And coming to the permissions, basically permissions are managed through policies. So set of policies becomes an overall permission, and this permission or a policy can be basically attached to a user, or can be attached to a group, or it can be attached to a role. And as we already know, IAM basically revolves around all these four objects, which are users, groups, policies, and role. Let's understand in depth about each and everything. So here IAM users can be an individual, or it can be a system, or it can be an application that requires access to AWS services. And with IAM, you can securely manage access to your AWS services by creating an IAM user for each employee within your organization. So instead of having or using root account for everything, so whenever a user joins an organization, you can basically create an IAM account for him, and you can share the credentials with him. So he will log in with his own IAM credentials. And each user account, each IAM account will have a unique name and also security credentials attached to it. So security credentials can be a password, or it can be an access key and secret access key. Again, we'll come back. So when these passwords are needed, when these access keys and secret access keys are needed. And also, in order to further protect his account, he can also set up multi-factor authentication for his IAM account. And each IAM user is associated with only one AWS account. IAM users needs passwords whenever they try to access the AWS Management Console. So if they want to access AWS services through UI, the graphical user interface, then they need to enter their password. But if they have to access AWS resources through programmatic access, like they wanted to automate something, then in this case they can use AWS CLI or AWS SDKs. So in this case, instead of entering the password, they can use access key and secret access key to authenticate with their AWS account. And coming to the IAM group, so basically IAM group is nothing but a collection of IAM users. So instead of managing users individually and managing the permissions individually, so what we can do is we can create an IAM group and put all our IAM users in that group. And remember, not all IAM users can be a part of the IAM group. So here I can create any number of IAM group. So I'll create IAM group for developers, IAM group for testers, and then I'll add selected users to those groups. And what is advantage of managing through a group is, so instead of managing the permissions individually to the individual IAM users, I can basically attach these permissions to a group. Now when I attach permissions to a group, so all the users who are part of this group can inherit those permissions. So whenever I add a new user, automatically he gets all the permissions that are assigned to that group. Now if I have to change permissions for all the users, I can basically change it to the group so that it will be inherited by all the users in that group. So managing permissions, by using IAM groups is much better way of managing the users. And remember, groups cannot be nested. You cannot create an IAM group inside an IAM group. And coming to the policies, which we already said, policies are nothing but the permissions. So whenever you create a IAM user within your AWS account, so that user doesn't necessarily have to have any access to the resources. So even if you create an IAM user without any access rights, he can still log into his AWS account, but he will not be able to do anything because he doesn't have any permissions. In fact, the default way is to not to assign any permissions to the IAM user. So depending upon his role, or depending upon his task requirements, we can assign only specific permissions for this IAM user. Let's say I want this IAM user to work on CloudFormation. So in this case, I will give him permissions only to access the CloudFormation service within AWS. So this is how the policies work. And as we already know, IAM policies define access control and permissions of various AWS resources. So if I have X user, I can assign certain policies for him, like listing all S3 buckets or creating EC2 instances. So I'll define a set of permissions for him. And in AWS, these policies are stored as JSON documents. So you can easily change or you can easily modify these JSON documents, and it is also easy to understand the policies because it is easily represented in JSON format. And one more thing, so IAM policy can be attached to a group, or it can be attached individually to a user. Also, it can be attached to a role. So this is a sample policy. If you see, this is a JSON formatted, and then you have effect, whether to allow or reject, deny. So here it has access through, so whoever gets this policy, so they have access to S3 service, and that to listing the buckets. And also if you see, they can also get the details of an S3 bucket through this particular statement. So this is a statement, this is a statement. So a set of statements becomes a policy, and this is JSON formatted. So now this IAM policy, I can attach it to a user, or I can attach to a group, so that all the users in that group will be inherited. And also I can attach it to a role. So this is IAM policy for the administrator access. So by default, the root user that is created with your AWS account will have this policy. So if you see, this policy has an effect of allow, action, anything, and any resource within the AWS account. So of course, this is not a full-fledged IAM tutorial where we'll start to create any IAM policy, but it is good to know how the IAM policy looks like. And this is how the policy works. First, a user is authenticated. So first authentication will be tested. Then depending upon the policy that is assigned for that user or a group, so authorization kicks in. So authorization will let's say I want to list a bucket. So first his authorization will be checked, like his policy will be checked. So if the policy allows the user to list a bucket, then the request will be accepted, otherwise it will be denied. So far we talked about IAM users, groups, and assigning various policies to them. Then what is this IAM role? So imagine I have basically a requirement, so that needs EC2 instances to access an S3 bucket. So here this EC2 instance is not a user. Okay, if he is a user, he would have the password to authenticate himself to S3 service. But here EC2 instance is a service. It is just like a bot. It is just like a process. So now how a process will authenticate? So process will not have any username, process will not have any password. So of course, if I take a process as a user, I can give a password based authentication for him. But here this EC2 instance is a service. The service is trying to access another service. So which means EC2 instance should have permissions to access S3 bucket. Okay, so policies I can create, but there is no user to assume that policy. So in this case, what will happen? So I'll use roles. So roles are like users, but roles are basically are meant to be used with services. So if a service needs to access any other AWS service, so that particular service should have the permission to access the other services. So this sort of accounts, we call them as roles inside AWS account. So you can take it as a bot, you can take it as another AWS service, or you can take it as some automation script. You can take it as anything. But there are certain differences between an IAM user and an IAM role, because we are saying IAM user is almost equal to an IAM role. IAM user is a physical user, like he has password, but IAM role, he also does the same thing. That means he also gets the policies and permissions. But what is the difference here? So here basically IAM user will have credentials. So using those credentials, he can authenticate or interact with AWS services. But roles here doesn't have credentials like passwords. Instead, so they will have access keys and secret access keys. They'll have certain temporary security credentials. But how these credentials will be given to a role? So basically, whenever a role is assumed by a service, automatically AWS will provide temporary security credentials for that role session. So whenever a role is attached to a particular AWS service like EC2 service, AWS makes sure that it injects temporary security credentials into that EC2 instance, as long as that role is used by that EC2 instance. And remember, roles are not permissions. Roles are just like your users. So permissions and policies are different. So here roles will have temporary credentials. That's the main difference between an IAM user and a role. So user will have long-term credentials such as passwords, but here roles will have temporary credentials managed by AWS. So this is one of the role. So if you see the role, this role is allowing access to EC2 service within the AWS. Now here, so this is a policy. So this policy has to I want this policy to be attached basically to an EC2 instance. So what I can do is I can basically use that role for this EC2 instance. So using that role will give EC2 instance the permission to access S3 buckets. So this is how your basically policies work. I mean roles and policies work. So here if you have an IAM policy, I can either attach it to an IAM user, or else I can attach it to an IAM group. Okay, and also if it is if you are assigning this to an IAM role, it can be a bot or it can be another AWS service. Okay, so what you can do is basically that IAM role will get access to AWS resources. Now let's understand since we understood the type of users, so let's understand AWS access type. So whenever you create a user in AWS, so you have an option to select the access type, like how the user will access your AWS. So whether it is through AWS management console, that is through graphical user interface, or it is through programmatic access. So programmatic access in the sense, so I've created a user to do some automation, like to automatically create S3 buckets or to automatically provision an EKS cluster. So for this I need not have access to the graphical user interface, because I'm not creating these resources from the UI. So if it is UI, it is simple, it is very simple. But here I wanted to automate it. I wanted to make the process much faster and robust. So in this case, so I'll create programmatic access. In case if I'm creating programmatic access for an IAM user, so he'll not have graphical user access. So he can only access AWS resources through any third-party utilities like any CLI tools, or they can access AWS resources through AWS CLI, or from any programs written in Go, Python, or developed through AWS SDKs. And always remember, so whenever a user gets access to an AWS account through management console, he will have a password. But whenever a user has to access AWS through programmatic access, he will have two keys. One is the access key, the other one is the secret access key. So using both these, he can authenticate to his AWS account, and depending upon the permissions that are assigned for this IAM user, so basically they can talk to various AWS resources. Now let's understand about AWS CLI, because as we said, if a user gets programmatic access, so he can control AWS resources through commands. So AWS CLI is a command line tool for working with AWS services, including EKS. So in fact, you can also create EKS cluster directly through AWS CLI. So it makes it easier to manage AWS resources rather than managing through console, because if you're managing through console, you have to navigate to each and every service, and that takes a lot of time. But if you are automating this whole process through a command line, so this is much faster. In fact, you can create your whole infrastructure. So if I have to show you this sample architecture, which is having two different subnets and different availability zones, and AWS RDS instance, and a web service, elastic load balancer, route 53 DNS service. So creating this particular stack will take a lot of time if you are going through AWS management console. But if you're doing the same thing with AWS CLI, it is much faster, because you don't have to navigate through infinite pages through get that architecture up and running. And also remember, in order to work with AWS CLI, you need IAM user with programmatic access, because first you need to configure AWS CLI with IAM users access key and programmatic access key, the secret access key, to talk to the AWS services. Now let's see why these IAM users are needed. So basically, we need to ensure security of our AWS resources by carefully controlling who has access to resources inside your AWS. By default, your AWS root account has unrestricted access to all the resources, which means, so if anyone gets access to the root account, they can do anything to your AWS account. So for this reason, AWS always recommends that you create IAM user and then grant granular permissions to those IAM users, just enough to complete their tasks. So if I have a task of working with S3 bucket, so giving permissions only till S3 service is the recommended way, instead of giving giving administrative level permissions to that IAM user. And also to make management easy, instead of creating IAM, managing IAM users permissions individually, it is better to put them inside an IAM group and manage permissions using that IAM group. And also programmatic access, which we already know. So using AWS CLIs, we can talk to the AWS services, and using programmatic access also, we can create, delete, update, or modify any AWS resources. So we need to also make sure that the programmatic access also has limited set of privileges within your AWS account. So just because programmatic access is just a CLI access, it doesn't mean that you cannot do anything with this programmatic access. In fact, if the root user has programmatic access through an AWS CLI, he can also do anything in your AWS account. And one more thing is, you should always protect your root account with multi-factor authentication. So there are a lot of online applications, like you have Google Authenticator, Microsoft Authenticator, and there are third-party authenticator or MFA applications. So make sure that your root account is protected through MFA. And in order to talk to AWS services through AWS CLI, so basically we need an IAM account. So root account is not used for security reasons, which we already know. And as we already discussed, AWS CLI has to be configured to talk to your AWS account. So using various commands, so I can configure the AWS CLI. And once my AWS CLI is configured with IAM users programmatic access credentials, so your AWS CLI creates two different files under .aws folder within your home directory. So automatically hidden folder will be created, and inside that hidden folder there are two files. One is configuration, the other one is the credentials. So the credentials file will have the credentials that are stored in plain text format, and the configuration will have the default output, default CLI output and default reason. So we'll understand all this when we basically do the practicals. And also once we have AWS CLI configured, we can practically do anything. So we'll also understand how to list S3 buckets or how to list EC2 instances using AWS CLI. So now what we'll do is we'll go through the official documentation and see how to create AWS IAM user, and also how to configure AWS CLI. So here I'm in my AWS account. So what I'm going to do now is, first let's understand EKS documentation. So I'll search for EKS in AWS. I'll just click on the first link, then get started with EKS, and scroll and just click on this documentation. So here you will understand what is EKS and all, which we already covered in the previous video. If you see here on the left hand side in getting started with AWS EKS, so here you need AWS CLI. Okay, so AWS CLI is pretty much needed in order to create EKS clusters through CLI. So that's the reason why we are basically working with AWS CLI. And also it is always recommended that you create an IAM user to create the cluster. So there is a specific reason. So if you are coming from Kubernetes background, so we know that Kubernetes, so when a Kubernetes cluster is created, so an admin account will be created. So these admin account credentials are automatically configured in the kubeconfig file if you are bootstrapping the cluster with kubeadm. So this first initial admin user has unrestricted access to the Kubernetes cluster. Similarly, whenever you are trying to create an EKS cluster within your AWS account, the current logged in account becomes the root account for that cluster. So not to mention, so here IAM is the default authentication methodology for EKS clusters. So the first user, the user that is currently logged in, or the user that is currently configured in AWS CLI, becomes the root user or admin user for your Kubernetes cluster. So it is always better not to use your root account while creating EKS cluster. So for that reason, we are actually going to see how to create an IAM user. So for that, what I'm going to do now is I'm going to go back to the management console, click on IAM. And if you see here, I did not set up MFA for my root account, so that's fine for now. So I'll click on users and click on add users. So this is identity and access management console. So username I am just giving as maybe developer. And here first we will see how to create EKS cluster through management console, that is through graphical user interface. In the next example, that is in the coming videos, we'll also see how to use EKS-CTL to create EKS clusters. For that, I don't need any graphical user interface access. I only need programmatic access. So for now, since I'm planning to show how to create EKS cluster using console, I'm going to use both access key, that is programmatic access, and also AWS management access. I'm going to select both for this particular user. But if you are planning to use EKS or create EKS cluster through AWS CLI, so there is no point in selecting this AWS management console access. And also, since I need password to log into AWS management console, so I would like to give my own password here. And here require password reset. No, it's not needed. And then click on permissions. So this is where you need to add permissions. So if you already have a group with a defined set of permissions, so what I can do is I can take this user and add to that group. Or else what I can do is, if I have a user with a set of permissions already assigned for him, then I can copy all the permissions from that user, The third one is attach policies. So I don't want to add this particular user to a group, or I don't have any policies readily available to copy from other user. So what I'm going to do is I'm going to attach policies. So as I said, policies are nothing but permissions. So if you see, the first one is the administrator access, which means if I give this policy to this developer IAM user, so he becomes an administrator, which means he'll have everything. He will have full control over your AWS account. And what I can do is, if I need if I have to give him access to only to the EC2 service, then what I can do is I can just give him EC2 full access. And in fact, if I have to give granular permissions, like within EC2 also, if I want to give him only read only access or access to some other thing, then I can fine tune the permissions. So here, since he is the first IAM user, so instead of giving him individual permissions, so I'll use administrator access. So this gives me admin level privileges, so that I can talk to any service, because initially I don't know what all services I'll be using to create EKS clusters, which means I cannot give fine-grained control to this IAM user. So that's the reason why, as a starting point, I'm giving him administrator access. Then click on next. So this will add some tags which I don't need. Click on review. So here, if you see, IAM user developer will have both programmatic and management console access, and he has administrator access because I want him to basically have access to anything within your AWS account. So let's just create his account. So now whenever an account is created with programmatic access, he will have access key ID and secret access key. But here I also created this user with management console, and I gave him basically a password also. So first, let's download this CSV file. So this CSV file will have all the credentials that are mentioned here. So if you open this CSV file, you will see so the URL that he has to use basically to log into the AWS console, and the access key and the secret access key. So everything is already here. So what I'm going to do now is basically I'm going to use this particular link to log in through this IAM user. So for this, I'm going to open some incognito, and then let's paste this link that is given by AWS. And then IAM user is developer, and the password is one which I already created. Since he has admin level privileges, so he should be able to see everything because he has got administrator level privileges. And coming to the next credentials, that is the secret access key and access key. So these we'll use to configure AWS CLI, so that using AWS CLI, he will be able to talk to the AWS account. Now so this is basically the currently the IAM user is logged in. So what I will do now is so this is the way to log in. So for now we don't do anything, because when we try to create EKS clusters using GUI, so then at that time we'll be logging to this AWS account through IAM user. But for now, let's not do anything with this IAM account. So this is how you create IAM user and assign various policies. So now let's see how this particular user can be used with the programmatic access. So for this, we need to understand how to use AWS CLI. So for this, I'm just searching for AWS CLI. So this is AWS command line that gives you access to AWS resources, and there are various documents that you can follow through to understand this AWS CLI and how to use it. So there is this command reference. So basically this command reference is used so if you want to work with AWS CLI commands and all. And here there is this user guide that explains how to install AWS CLI and all. So let's click on this user guide first. So here in the next line, if you see, so this is complete information about how to use the CLI, and also how to work with various services within AWS. And coming to the AWS command line, so here you can install it on Linux, you can install it on Windows, and once it is installed, basically you can use AWS hyphen version to basically check the version. And here so I can just use this getting started to start with this AWS CLI. So coming to the prerequisites, so basically you need an IAM account, AWS account, and secret access key and access key, which we already have. And let's click on this install and update. And here if you see, we have two versions. AWS CLI version 2 is the latest one. Let's click on this Windows to install this AWS CLI for Windows. So if you're on Linux, you can use any of the package managers, or directly you can download this zip file and install. So all the instructions are clearly documented. So let's proceed with Windows. So in Windows, what I can do is I can just click on this file. So this will download the .msa file for this AWS CLI. So let's install it. Let's click on next, accept the terms, next. So now AWS CLI is installed. Let's click on finish. So now what we can do is we can open any command prompt. So you can use git bash, or if you have any terminals you can use. Now once it is installed, I can just do AWS hyphen version, and this will return AWS CLI version. So it is returning AWS CLI 2.9.3, and it also requires Python. Since I already have, it did not ask for this dependency. So if you don't have, I think you should also install Python. And once this is installed, so what you need to do is you need to click on this configure AWS CLI. So this is what we need to do. So let's click on configuration basics. So here, as we already said, in order to use AWS CLI, so we need IAM user. And since we already have IAM user created, and that IAM user has access key and secret access key, so what we can do is we can directly configure it. And once you configure AWS CLI, as we already seen, it creates two different files, config and credentials, under your user home directory. And then what we can do is, so in order to configure, I can use AWS configure command. So let's do AWS configure, and it is asking for AWS access key. So I can open this Excel sheet, and this is the access key. So I can simply paste it. Then it is asking for the secret access key. So just paste the secret access key, and then the default reason. So default reason is basically your region near to you. So you can use any region. So for me, I'm near to Mumbai region. So what I'll be doing is I'm going to select Mumbai. So if you select Mumbai, it will also show you the here AP-South one, so which is the basically the region code. So AP South 1. And here the default output, if you don't want to change it, basically you can actually click on click enter. So this will take the default output format. But if you want to dig deeper, what I can do is basically I can click on AWS configure again, but this time I can just see the help options, or so here I think I can use AWS -h maybe. No, this is also not working. If I do -h, so this is also not showing. Let's see the official documentation if it gives anything about the output format. So here, so to create access keys, we need IAM user, so which we already did. And the reason, yeah, so this is where output formats are mentioned. So if you see, output format can be JSON, and this is the default one. So JSON is the default one. Now you can also use YAML text table. So I'll show you how to basically use the table format. And one thing that you need to understand is that once an AWS CLI is configured, so if you go to your home directory, so within Linux you can go to your home directory. So within Windows, if you go to your home directory, so there will be this AWS folder. So within this AWS folder, it will create two different files. So one is the config. So config, if you see, these are the defaults. So reason is AP South one. So if I change the output format, even that value will come here. But if you look at the other file, which is a credential file, so these are the credentials basically. So your access key and secret access key that you just copied from your Excel sheet will be shown here. So now that we have configured your AWS CLI, what I can do is basically I can use AWS CLI to do any sort of operations. So let me open the command prompt again. So what I'll do is basically I'll use AWS. So I wanted to work with S3, so let's do S3. But since I don't know anything regarding the commands, so let's use AWS S3 -help. So I'm not sure why this is not working here. So basically -help should give me the possible list of commands. So let's see what are the various services I can talk to using AWS CLI. So let's click on using AWS CLI, and then if you go to this command structure, so if you see, so there is this AWS command and sub command. If you see the examples, so if I have to work with if I have to see the buckets, so I can use AWS S3 LS. So if I enter this so basically I will be able to see the all the buckets, since I don't have all the any of the S3 buckets, so this is an empty list. What if I have to see the so basically the EC2 instances? So I can click on this using AWS CLI with AWS services. Then probably I can so I have to work with EC2. So I think it is not given, but I have given in the presentation. So I can go to this particular link that will show me various commands that I can use to work with EC2. So here if you see, this is for launching, listing and terminating AWS EC2 instances using CLI. So I wanted to list instances, so I'll click on list instances. So this is a command, AWS EC2 describe instances. So usually the help section should work, but I'm not sure why this is not working, or maybe the command is wrong. So if you see AWS EC2 describe instances, it should show me all the instances. So there is this one instance, I think, so which is actually running, and the reason why it is being shown in this format is because, so the default format which I have is the JSON format. So of course I can also change the format to a table. If I go back to get configure AWS CLI, configuring the basics, so here if you see the output format, I can also simply put it as a table. If I click on this table, okay, which means I can dynamically see the output in various formats instead of actually configuring them. So this is much better. So here I'll use the same command, so that is AWS EC2 describe instances, and output I wanted to get in the form of table.
So if you see, it is giving me a response, but it is hard to understand. So what I'll do is, let me open a different command prompt. So let me open git bash maybe. So let's see how this works. So AWS EC2 describe instances and output in the form of okay. So output, I wanted to show it in the form of table. Yeah, so this is much better. So this is giving the output in much better way. So if you see, these are in the table format, so it is giving me more a lot of information. And also I can see the information in the form of YAML. See, this is also very easy to read. So in fact, I feel YAML is much more comfortable way of representing the information than JSON, because the JSON document will have see, it is very difficult to read the information. Of course, JSON is the much better output formatting way in order to parse the information, but YAML makes it easier to read the information. So this is how you use AWS CLI, and this is how you configure it and talk to AWS services. So the main reason that we configure AWS CLI is, so in one of our upcoming video we'll understand how to use AWS CLI in order to provision EKS clusters. So that's it for this video, and I'll see you in the next one.